Hello, my name is Pedro Arduino and I'm a professor at the University of Washington. I am also part of the Sim Center group. Today I will be talking about an educational tool called the PileGroup application developed by the Sim Center developing team. The idea of the tool is to introduce concept of pile response when subject to lateral loads and embedded into a layered soil system. The tool runs in the background the OpenSys platform and includes a graphical user interface that has been designed in order to facilitate the interaction between the user and the OpenSys platform. The tool can be downloaded directly from the Sim Center website that is available in the Design Safe Cyber Infrastructure portal. By downloading the tool, it's going to be saved in one of your folders in your machine, and by double-clicking into this tool, a main window is going to be loaded. The main window shows a default configuration of a single pile in a 3-layer system. The central window shows the pile configuration. The right window shows plots representing the response of the pile to a lateral load. This response is expressed in terms of a displacement profile, bending moment, shear forces, effective stresses, and parameters defining the springs that connect the pile with the soil. These parameters are the P-ultimate and the Y50. To the left, there is a window with some hints on the use of the tool, and below there are two windows, one representing the pile system configuration and the other one representing the soil configuration. The pile configuration is expressed in terms of number of piles, the offset between the piles, pile diameter, embedded length, length above the ground, and the Young modulus of each of the piles. The soil configuration is expressed in terms of the thickness of the layers, dry unit weight and saturated unit weight, friction angle, and shear modulus. At the top, there is a scrolling bar that allows to change the lateral load that is applied to the top of the pile. By moving this bar, it is possible to change the load in the pile, and by doing that, the response is updated in quasi real time. At any moment, it is possible to change the properties of the soil or the piles. For example, if one chooses soil properties, one can choose any of the 3 layers in the system and change the thickness or some of the other parameters. It's also possible to change the location of the groundwater table, and by doing that, the properties are going to change accordingly. One can choose any of the layers either by clicking into the corresponding box or by choosing a different layer using the mouse. Once you selected the layer, it's possible to change some of the properties of that particular layer. It's also possible to change the characteristics or the properties of the pile. For example, the pile diameter by default is set to 1 meter, but that value can be changed. And by doing that, again, the response of the pile is going to change accordingly. We can also change the embedded length or the Young modulus of the pile. By default, the Young modulus is set to 1 gigapascal. It's important to know that all the units are also shown in this box, so that it simplifies the appreciation of the type of numbers that are being used in the tool. It's also possible to add piles. By clicking into the Add New Pile, it's possible to add 1 to 3 piles. Once we have added piles, it's possible to change some of the properties of these piles or the configuration. For example, we can choose in this pile, it's possible to change the diameter. We can increase the diameter, for example, and by doing that, the response is going to change. We can choose another pile just by clicking into the drawing, and we can change some of the properties. For example, we can change the embedded length and make the embedded length a little bit different. And again, we can also change, for example, the diameter of the pile. As we make these changes, the response is updated accordingly. There is some information that can be changed in this analysis tab, in particular the finite element parameters. Right now, in this initial version, we only allow to change the number of plots that can be shown in the right side of the tool. In a version 2, we are thinking about giving more flexibility, including more piles, more number of layers, and also some of the information that is relevant for the finite element analysis, including number of layers, type of tolerance that is used, elements above the ground, and so forth. Again, the tool has been developed keeping in mind that it's going to be used by undergraduate and graduate students, and with the idea of introducing concept of lateral loads on piles when they are embedded into a layer system. For now, this is all. Hopefully this is useful for you. Thank you.